Hello and welcome back to the 7th part of the Harrier story. You see a lot of new things has entered this table and we want to talk about them. Yeah? These are mainly test stands, because we had to do a lot of tests for several parts of the Harrier, bending and load tests and so on, to make sure that all the parts we put in this jet, that they stay and that they do what they should do. And what you see here are test stands at first for yaw. This is what the fuselage is put on. This is yaw test stands on which the fuselage can rotate. This is for test the power of this yaw nozzle. This yaw nozzle will installed here on the tail of the Harrier and stabilizes for yaw while hovering, and this should be also done while slow flight. And the next is this bending test stand. Here is already the spar installed. The spar we built in the last part. This is a composite part made with a 3D printed core and composite reinforced. And we want to know how much load can this spar hold. So in this video we will break it. So and let's see how much load it withstands. And here we got a gear test stand. This is for the landing gear. At the moment there is the SUX landing gear installed, but later on we want to build the gears for the Harrier, and we think over to 3D print them also, and to check if they withstand the rough surfaces on a grass bottom start. We want to first check them here in this machine, and I want to also show you how this was built and also the first test with the SUX gear. We can do two kinds of tests. First, to simulate a very rough surface with this rotating barrel. This simulates a rough grass surface, and the second is a drop test. Here are weights installed that simulate the weight of the whole airplane, and the whole bar, this bar gets up and then it can let go, fall down, about 20 centimeter. Maybe when you have a bad landing, when you flare too high and you suck through. This should be also simulated. Of if this gear holds all these forces, and at the end I have something very cool. You see this here in front. This is a completely 3D printed, lightweight PLA 3D printed main fuselage part of a Harrier. This is a little bit smaller than this one, only for one 90mm EDF, and with this Harrier we want to do the first horizontal flights. This will be completely 3D printed, also the wings and everything else, and we want to see if the aerodynamics work or if there are some changes needed before we go to this big one. And I would say let's start this video, and we start with the building process of this rotating jig. So let's go. So here we are. The next step is building a support on the Harrier fuselage on the lower side. This is for our yaw testing. So I will close this hatch and put some tape on here, and afterwards there will be laminated a patch put in here and let cured that fits good on the Harrier fuselage. Let's go. So the surface is covered. I'm using this paper tape because it follows very nice on the surface, and you can press out any waves and bubbles so that you have a very nice surface. Otherwise, to plastic tape everywhere would be some bubbles, and there are mostly problems while removing this plastic tape. And the next step is put some wax on the surface. Yeah, I'm using this liquid wax. Yeah, and put it on with a brush, just to make sure that no resin comes through the tape and for easy release of the tape itself from the laminate. So next step is marking the area for the laminate patch. Underneath I put a small tape which shows me the line, and it's easy to go along this line with this pencil. So I put on a plastic film, and this is a schablon for the laminate, and now I mark the outer line of my patch, and I also write on top that the side where I have marked with my brush don't go to the laminate. So this is ply number 6, and you can see with this spatula we can easily bring the resin into the fibers. And this is the last ply from the 280 fiberglass. This I press into to that it can suck the resin from the underneath plies to have a good fiber to resin ratio. And on the color you can see that we have no bubbles inside. The laminate looks really nice. And now I put on the schablon with top on top, and then I use again this electric cutter and cut the whole plug to the correct size. So here we got our plug. Turn it around, remove this side. So the plug is installed on the fuselage. I removed the bubbles with the roll, and now it's time for our wood. Here I put some resin on for good bonding, and now there will be applied the micro balloon cotton flocks mixture. This looks like this, and now I put the whole piece in the center of this plug. I go forward and back and press it down that the mixture is pressed out, and the excess here I level with the brush. So now everything is ready installed, and the last thing is check the alignment. If the wood block stays vertical on the fuselage, everything looks nice. And now the resin can cure. For speeding up the curing process of the resin, I am using this red heat light. And at the moment we got 36 degrees. This is quite okay. Yeah, it's curing. So now it's cured and it's time to demold it. Let's go. Here it is, our part. The wax works nice. So here we got our upper part, shell, where the fuselage will be mounted on. And now we have to go on with the lower part. For this I will use this aluminium block. Put in this ball bearings, and in this ball bearings comes this carbon rod. Yes, and you see here underneath there are already the holes, and then hopefully this can easily rotate on this little table. So let's go. So all holes are drilled. The next is put in the ball bearing. So next is these little foots for a good stand on the table. So now it stands good. Okay, it works nice. So this is my first try for the test bench. To see over here, in the center there I will put the scale. They will be mounted here, and on both sides we have electric actuators that will level up. And the first step is to give them a new paint that they look nice. The first one is done, and now it's time for the second one. I will also remove this, that it is a little bit smaller, and then give it a new paint. Let's go! Here's a view on the inside of this linear motors. Here we have an electric motor with a gear, with an angled gear. The same also. And now they will be installed on this horizontal bars. Yeah, and here it is. The test bed, it is ready working, can go up and down, and also the scale is installed. But one thing there has to be improved. While pulling up to 200 kilograms, there was a bending tendency of this whole part in this direction. So I want to reinforce it with some aluminium profiles like this. They will be installed here. I hope you can see this, yeah, to stiffen this bars, yeah, and hopefully then we can go over 200 kilogram till about 300. Let's see. So let's go. Installing the screws, I need this 2-in-1 drill. This is a drill combined with a thread cutter. So everything is ready assembled, and I would say let's do the first load test. 95, 120, 150. You can see this there. 180, 200, 212. Yes, and then it sucks slowly up, so I would say this is the maximum that is possible for this machine, but for modeling I would say this is quite enough, 200 grams. When you listen to this, this is hard like something, oh my god. Yeah, and it stays almost at this load at 200 kilos pull. And this is what it should be, yeah, for the testing. For instance, for the spar, with this I will start first, yeah. So I'm quite happy with this machine. So beside our static tests, like this one with the main spar, I want to do also some dynamic testing, especially with the gear. Here we got a gear from the SUX, and for this I will build a new test bench. I already put the parts that will be needed in here, and I want to explain a little bit how this should look like. Yeah? The heart of it is an electric motor that drives that barrel. That barrel is driven eccentric, yeah, so this will wobble a lot, and it brings forces on the gear. Yeah? This gear will be installed underneath of this bar. On top of the bar I will put these weights that simulate the load of the airplane. Yeah, and all this should be mounted on this white board here. Yeah, and I would say let's start building it. So I'm starting with preparing this wood bar, and I want to round up these sharp edges. This is important for later handling, and this will be done with this air grinder, 120 grit. Let's go. First parts are made. Here we got them, these wood bars. Next is putting the engine on this flange, and for this I have to widen these big holes and drill some small holes, and then we will install and check the torque of this engine if it is strong enough. So let's go. This really super massive material here, this angel, but nevertheless it fits perfect. Yeah. So the engine is centered, and the next are the 3 holes for this M3 threaded bolts. Works out well. The screws are fastened. So the next part is installing this barrel on the end of the motor, something like this. Yeah, on the barrel itself here should touch the wheel of the gear. Yeah. And now I have to build an adapter. I think I will do this out of this wood. Yeah. I will cut out a circle and glue it inside, and this will be adapted to the end of the motor. So let's go. So the first test run, and we can see it does what it should. Yeah, this is for the gear, that it goes up and down, and in this area it should run smooth. Yeah, here this is almost good enough, so that we can glue the backside, and then we can install it on the bottom plate. Here it is, the first parts are assembled. Now we can have an idea how it will look like. Yeah. The vertical Wood bars are assembled on the bottom plate. Here's the barrel with the motor, and I put in an SUX gear, yeah, and this bar will go up and down when this starts rotating. And now this has to be bolted on, and the battery has to be installed, and especially the weights, yeah, the holder for the weight, and then we can do the first test run. The last thing is installing a second weight holder here, that when the gear is positioned here for drop testing, the weights should be most exactly over the gear itself, yeah, to simulate the real flight weight. Yeah, that's why the second holder will be installed. And last but not least, these small handles come at the end of this 6mm metal rod. These are the rods for positioning this horizontal bar, for easy in and out. Yeah, and then it should be finished. So I would say it's time for our load test. Two cameras are installed to see from both sides where the first cracks come up on the spar. And I would say let's pull up this thing. Okay, I'm starting. 5 kilo. First crack. 7 kilo. 8. 10. 12. I think this is just the wood. Yeah, it's not the spar itself. 14. 16. 20. Just check the cams. Okay. Oh, 20. 25. It's not broken, it's still the wood, it's still the wood. 29. It's bending. 30. 33. 'Something something is breaking in there. Over there it seems to start breaking. And this area, it breaks. Okay, it's the maximum I can pull up. it's still breaking. Okay, it's completely damaged. Now the carbon is broken. So, we got a result for our load test. The spar is broken. That means about a load factor of 10G. Yeah? The weight of the jet will a little bit about 6 kilogram. So if we had pulled on both wings, we had pulled 60 kilograms. This is factor 10, and also we pulled very on the outside. Normally the center of lift is more inner. Yeah, so much over 10G would be possible to fly with this jet, and this is what we will never do. This is not a hard acrobatic jet, the Harrier. Yeah, so we can use much less of this carbon rovings for the rear wing that we want to build up. Yeah. And let's come to the last part of this video. This is our main fuselage segment for the smaller, fully 3D printed Harrier. Yeah, and I want to show you a little bit how the print process looks like. Yeah, and don't worry when you see all these little worms. This is because we print with this lightweight PLA, and on this we can't use the retraction on the printer because this is foaming and this would block our nozzle if we use the retract. So there is no retract, and this is why there are these worms are all over there, but it's not a big problem. They are really easy to remove. Yeah, and a little bit more problematic is the support. Yeah, the support inside the ducting, but I will show you how I did it and which tools I used. Here we got the first fully lightweight print Harrier main section. This is for the horizontal flight version for 190mm EDF, and at the moment it is full of the support and of some strings and little worms from the lightweight PLA print process. Let's take a look at the weight. 163 grams, and let's see how much it is after removing the support. Let's go. Ducting become more and more free from the support. At the moment it looks like this, and I'm working with this chisels, this straight one and this one with very sharpened edges, and with this I can stitch and remove the support from the surface without destroying the ducting itself. Yeah. It takes some time, but it goes on step by step and it comes out really nice. Here we got the tools I was using to remove the support on the 3D printed parts. We have these long pliers, yeah, to grab in, then rotate and get it out. Yeah. Then I really like these chisels. They are really sharp chisels. One is with a top on the end and one is flat. These two are my favorites. And also I'm using 120, 80 and 60 grit sandpaper, these pieces. And then I have several tools. Yeah, this for instance is curved. This is a curved sandpaper file. This is a little bigger one for different kind of radius. Yeah, and the other tools are custom made. by myself. I'm using this stripes of carbon. Yeah, this is stiff but also flexible. Yeah, and you can use the thickness of carbon that you needed. And on this I put this two-side tape, and on the two-side tape I put the sandpaper. Yeah, and after this it looks like this. Yeah, and this is a sandpaper file. Yeah, which is flexible, and you can get in and under the nozzles. Yeah, and that's how I do. So, and this was it for this video. I hope you enjoyed this. Yeah, if you want to support this channel and support what we do, you will see a link under the description for buy me a coffee. So if you like to, let's buy me a coffee, and we will see us in the next video. Bye bye.